Hey there, I just wanted to make a quick video to kind of explain the questions that were coming up in class, and then since we didn't get to finish the check understanding questions here. So, with the research here that's being done on these teenagers and, then the conclusion about the teenagers who eat with their families at least 5 times a week are more likely to get better grades in school, and asking what is the statistical question that the researchers were trying to answer. So, the question that they're trying to answer is there an association between the number of times a teen eats with their family, and their grades? And so, kind of the questions that were coming up in class about that, that is a yes or no question. Is there association? Right? That's a yes or no question. What the issue here, why this is valid, because the data that the conclusion is based off of data that can vary. The conclusion or the research would come from data that can vary, or would be based off of data that can vary. So that's kind of the idea, like how to kind of wrap your head around that. This is a yes or no question, but it's a valid statistical question because the conclusion is based off of data that can vary. So if I asked, the question and like, what's the average height of the students in my classroom, there would be only one answer to that. But that answer is going to come from me asking, all you guys how tall you are, and then that data varying from person to person. So it would end up being a valid statistical question. Just to kind of look at a couple more examples of that, like how you're going to be asked this in the homework and test. Identifying the population and the sample for this, I generally think it's easier to identify the population first. And then think about what the sample is later. I think that identifying the sample is easier, and then go over to the population later. So the sample is usually stated in the question. So like up here they say, they randomly selected 1,000 teenagers in the United States. So there's our sample, 1,000 teenagers in the United States. You do want to give like a number. You want to be specific. It's not just 1,000 teens. It's 1,000 teens in the United States. And so then what we say is the population. So the population is the larger group that the sample came from. And since they sampled 1,000 teens in the U.S., and we kind of have to assume that means from across the U.S., like from multiple states or a bunch, hopefully from every state, that the population would be teenagers in the United States. So we could not take this data and I'm going to say, let's change that. So all teenagers in the United States. We cannot take this data and say that teens across the world will react this way, or will show this association. So we cannot say that all kids across the United States would have this association, because our data is only for teens. Our data is only about people in the United States. If I was trying to answer this same question, but I only sampled students, teenagers that were in Kansas, I would not be able to take that data and then apply it to the broader United States, because I'm only looking at students in Kansas. Maybe there's something different about Kansas and families and grading and stuff like that that makes the association here different. So, if I was going to collect data from the class, the analysis class, I could not say, then expand that to say, oh, here's how students at Free State think or do or whatever, because I'm only looking at a small sample. That I would need to have a broader sample. I shouldn't say small, but a select sample that, in one classroom, you guys, are not a representative group of the school. I need to look at, make sure I have freshmen and sophomores and juniors and seniors and from different areas of the school. So I'm making sure I get students that doing like tech classes, students that are doing art classes, students that are doing gym classes, students are in English and math and history. Like I want to get a broader sample so I can talk about the whole school. If I want to do that, and then even if I got that for the school, I could not then say that high schoolers in Kansas do this, because Lawrence could have something very different about it than other cities in the in the state. So if I took a sample from the school, I could talk about the school. I couldn't even talk about you guys compared to LHS. It wouldn't work that way. So it can't over expand your population. When it's gonna be important that we talk about that more. And then, is this an observational study or an experiment? So remember, the difference here is there a treatment being imposed, or are they just asking questions? So this is an observational study because the researchers are just asking the teens, like, how many meals do you eat with your parents, and what are your grades? They're not asking them to change their behavior and then come back and look at data later. So the researchers are not imposing a treatment, is the kind of the technical way of saying it. If I could spell. Are not imposing a treatment. Kind of another way to think about it is that they're just asking questions. If they, went back to those teens and said, okay, well, now this group's gonna stop eating dinner with their families, and this group's gonna increase the number of times they eat with their families, and then come back later and then collect data on their grades and see how things change, that would all of a sudden be imposing a treatment and change it to an experiment. So you might want to read through the definitions and stuff in the textbook, the examples in the textbook as you're looking at stuff if you find yourself being confused. But hopefully that helped a little bit. Thanks. Like that. It'd be something like this, so just determine if each is a valid statistical question and explain your answer. So how much money does Mr. Tagawa have in his wallet right now? So that is a non-statistical question. There is only one answer to that. The answer should not vary from person to person. So this would be a non-valid statistical question. Or a non-statistical question. And then, how long can students at your school hold their breath on average? So like, again, the end result would be I'd have one answer to this, that the average length of students hold their breath. But where did that answer come from? It came from data that could vary from student to student. So this is a valid question. And because each student will have a different length of time they can hold their breath. And so, the collection of all that data would create a valid statistical question. What proportion of U.S. adults engage in vigorous exercise at least a week? Again, the end result of that would be one answer, that 3/5 of adults, or 1/12 of adults, engage in vigorous exercise. So there's one answer to that in the final result, but where that answer came from, again, is from multiple people giving different answers. And so this is a valid statistical question, right? That the data collection would have resulted from, would result in multiple answers that we would then average or whatnot. And so you don't have to average. And I know both of these talk about averaging. You don't have to average it to be statistical. It's just that these do that. You can't have an answer, but it came from averaging other answers, versus just like something that's just straight factual, like on A. So hopefully that helps a little bit on that.